Okay, so first of all, we're going to be looking at machine learning. So in the world today, machine learning has become a technology that has been used in every field. Almost every field, machine learning has its application. So what is really this machine learning? Probably you might have heard about machine learning, or probably you might be curious, you might be interested to know what it's really about. So what is machine learning? Machine learning, it's a field. It's a field in computer science that focuses on creating systems that can learn from data and then make decisions based on this data. So machine learning is like this teaching this computer to learn from this data, and then this computer will now have experience to make decisions like humans do. So imagine a machine learning system. Let me give you a practical example of a machine learning system. For example, we want to develop a system to recognize a type of fruit. So we'll show this to recognize like different type of fruits. So we'll train the system with different types of fruits, tell it the name of the various fruits. So then the machine is trained to remember the name of those fruits. And after a while, when you show it a new fruit, it can recognize that fruit based on what it has been trained on. So that is just similar to the process, how machine learning works. It's just like how the mind works. If I show you various fruit, then when I show you another one, you can now understand it. Okay. So I'm going to very quickly now, I'm going to explain the processes involved in machine learning. During the course of the meeting, if you have any question, you can raise your hand, type it in the comment section, but there'll be a time for question and answers. If you have any question, you can just stop me, then I'll answer your question immediately. So the process for machine learning, the first process for machine learning, like I just explained just now, is learning from data. Yes. So machine learning, you are feeding lots of data to the computer to learn. The data could be pictures, it could be text, it could be numbers, it could even be sounds. That is machine learning. So the computer uses this data to learn patterns. So when you have trained it on large number of data sets on these things, it might not even assume it might not always be really large. So when you are training with these things, it works with these things. That is the first stage in machine learning, learning from data. Then the second stage in machine learning is making predictions. Let me share my, I'm coming, let me share my, okay, you can see, all see my screen. You can see my screen. Good. So I said the first stage in machine learning is learning from data. The first stage, then the second stage is making predictions. So when this computer has learned from data, it can now start making decisions. For example, like I said, you have learned what the various fruits looks like. You can now look at a new fruit and tell, oh, this is this fruit. Or if it was various species of flower, after he has been trained on numerous samples of, let's for example, 3 types of flower, you can now look at this and identify this is this particular species of this flower. And that is it. Then the third process in machine learning, the third process involved is that it improves over time. So the machine learning is trained to improve over time. The more data it gets, the more it learns, the better it becomes. Think of it as, for example, the more fruits, in that example of identifying fruits, the more fruits you see, the more you become better at seeing a fruit and identify it, oh, this is this fruit. So machine learning, you learn from data, it makes decisions, it improves over time. What type of data can be used for machine learning? Various type of data can be used. Like I said, it can work with digits, it can work with text, it can work with images, it can even work with sound. Yes. So now let's go to some practical applications of machine learning. Yes. So the first one we're going to be looking at is email filtering. So you would have probably noticed how sometimes your mail service provider would classify some email as spam, the spam category, and then the emails you normally see. This is because he has analyzed the incoming emails, and he has classified them based on patterns from previous data. Maybe this sender, he has observed this type of messages this sender sent. So that email filtering is a machine learning system that was trained that is doing that. Then recommendation systems. You probably use platforms like Netflix, Amazon, YouTube. So this platform, they use machine learning to suggest products, movies, or even like YouTube Music or Spotify uses machine learning to suggest new music based on your taste. You would have studied your taste. For example, you finish watching an interesting series. It has studied it. Almost everybody that finished watching this movie probably want to see this other movie. So what does it do? After you have watched this movie, it then predicts this other movie. Which movie can we use for an example? Let me see. I cannot really think of a movie now, but I hope you really understand what I'm trying to say. Things like Amazon, it's like he has studied the type of things you buy, and then he predicts things you like. Like for example, if you are buying something like if you are buying cushion utensils, if you are buying one cushion utensil, probably like a pot, it can suggest to you also to buy spoons, to buy other cushion utensils because it observes what you are buying. That is the data that is trained on. There's a recommendation system that are used. They also use machine learning. And then image recognition. Image recognition. When you upload, when you use things like Google Lens, that is image recognition in action. So how does that thing work? It has been trained on various sample data on things like that. So the algorithms can now identify objects, people, but he has been trained on a large amount of data. So you can now look and know, oh, this is a cat, this is a dog, because it has been trained on various samples of cats and dog. And you know what cats and dog looks like? That is one practical application of machine learning, image recognition. There are a lot of practical application, fraud detection, yes, yeah, there are just a whole lot. So very quickly now, I would just want to briefly explain the difference between artificial intelligence, machine learning, and then deep learning, because I think some people usually mix these things up: artificial intelligence, machine learning, deep learning. So let me explain the difference like this. Artificial intelligence is a broad field in computer science. So the goal of artificial intelligence is creating systems that can perform tasks that usually require like human intelligence. So this artificial intelligence, the goal is you are creating something that can learn, that can solve problems, that can understand things that might usually require human intelligence. A computer cannot do. That is artificial intelligence. Then what is machine learning? Machine learning is a subset of artificial intelligence. Machine learning focuses on creating systems that can learn from data and then make decisions from that data. That instead of being programmed with specific instructions, machine learning algorithms can find patterns in data and then make decisions based on this data. Then deep learning is a part of machine learning. I hope you are following. So machine learning is a part of artificial intelligence. Then deep learning is a subset under machine learning. Deep learning uses neural networks with many layers to learn complex patterns in data. So these neural networks, they are inspired by how neurons are being transmitted from the human brain. So that is just the similarities and difference between them. So AI is the broadest concept. It includes any technology that enables machines to perform tasks that require human intelligence. Then machine learning is a subset of AI. Machine learning is a subset of AI. Not all forms of artificial intelligence uses machine learning. Yes, but all machine learning is artificial intelligence. Then deep learning is a subset of machine learning. Deep learning uses deep neural networks to learn from data. All deep learning is machine learning. So I really hope you understand it. So if we were to visualize this, I'd really love if we could visualize it. So using three cycles, one inside the other, the largest cycle would be AI. Then inside this circle, a smaller one will be machine learning. And within this small cycle of machine learning, a smaller one will be deep learning. Yes, this shows that deep learning is a type of machine learning, which is a special type of AI. Yes, I hope this is very clear. So moving on, let's look at the types of machine learning. The types of machine learning algorithms. So there are primarily three types of machine learning algorithms. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. So let me quickly go through them. So supervised learning. Supervised learning is a type of machine learning where you train a model by using a data set that has both input data and output data. That is, it has labels, it has features, and it has labels. The data set is complete. It has features, it has labels. Each piece of input data also has a corresponding output. So the goal of supervised learning, you are training it to like look at this input, look at this output. It's observing whenever there is this input, this will be the output. How does supervised learning works? It works like this. You train the model is given a large amount of data with known inputs and outputs. For example, let's say we want to predict house prices. Yes. So let's use something simple, a very simple model. So we're looking at something like size of the house. Size of the house. Okay, how size of the house affects price. So something like supervised learning, we have the price of the house. We have the size, then we also have price. The size is the feature. Let's assume we have size of the house and then the bedrooms, number of bedrooms. So with these two features, we have a label. The label would be the price. So those what are the things that determine the price? The size of the house and the number of rooms in the house. So in supervised learning, we have the features. Those are the size of the house and the number of rooms. And then we also have the label. The label is the price. So supervised learning will give it the features, also give it the label. Yes, so the machine learning model, it looks at this input data and the corresponding outputs. Then it learns the relationship between them. It finds the pattern in the data that helps it predict the output. What is the relationship between the input and output? So that is how supervised learning works. It studies the data. What are these? What is it like a positive relationship? These inputs keep increasing in price, the output keeps increasing. That is how supervised learning works. It studies the relationship. It draws out the relationship between the inputs and the outputs. And then when it is trained, it can give new, when you give it new input data, for example, for a new house, you now give it just the size of the house. That is the size of the house and the number of rooms. Because you have trained it on several number of size of house and number of rooms, it cannot predict the price. Yes, I really hope you understand. If there's any question, just raise your hand up and I'll stop to answer your question. But that is it. So once you are trained it using supervised learning, it can now predict the price of the house. If you now give it only input, it cannot predict the output because you have given it several input and output. It has now studied that. Yes, probably the relationship between that and the larger the house, the larger the size of rooms, the more expensive the price will be. A positive relationship. If we study this data, draw out a relationship between it. So that is it for supervised learning. And then the next one, unsupervised learning. Yes. So unsupervised learning is a type of machine learning where the model is trained using data that does not have labels. Good. This one is very, very different. Just pay attention and you understand it. It's very, very straightforward. So unsupervised learning, we're using data that don't have labels. So the model tries to find patterns or structures in the data on its own. You're not giving it labels. It will find the structure on its own without being told what to look for. It looks for similar pieces of data together based on their features. This is for unsupervised learning. So let me explain how this unsupervised learning works. Okay, this is how unsupervised learning works. So let's assume the model is trained on a large amount of data, but there are no labels. For example, if we have customer data, we have information about their purchases, their history, their age, their location, but then we don't have categories or group for them. We just have various data about these customers. So this machine learning model, it can analyze the data, then look for patterns between these people that patronize this store. Yes, then this group, we group them in something we call clusters. So it studies, when I give it the data of the various customers that patronize my store, I did not label the data. But then we study this data, study the similarities between these data, and then we group them in something called clusters. Take note of that word, clusters. So when it has grouped them in clusters, it now helps us to understand the structure of this data. It shows us these clusters. Then we can now use this information to make decisions. You can use this information to further analyze the data. Yeah, so imagine, like the example I gave, imagine you run a store and you have data on like customer purchases. You don't know in advance which customers are similar. Yes, but you want to find that, you want to know the similarities between various customers. If you were to group your customers, how could these people be grouped? So use unsupervised learning, analyze it based on what they purchase. So the more they group them, people that buy similar products together, so that you can get more information about them. This can help you to identify the customer segment. Yes, you will now know the budget shoppers, the frequent buyers, people that you will now know, people that come very, very regularly, the luxury shoppers. So that is how unsupervised learning works. You train it without data, but then it learns the pattern and structure from the data by itself. Yes, so that's it. And then the next one I'm looking at is reinforcement learning. Yes. So how does reinforcement learning works? Reinforcement learning is a type of machine learning where a model learns to make a sequence of decisions by interacting with the environment. Yes, I know you wonder, what do I mean by that? So how this model is being trained, it gets feedback in form of reward or penalties based on its actions. This reinforcement learning is learning based on the various decisions it's making. It keeps learning. So it goes to, is to learn a strategy that maximizes the total reward over time. It keeps learning. Let me explain further this reinforcement learning. So this reinforcement learning, we have the model, let's assume the model, let's call it our agents, interact with the environment. The environment can be anything. The environment is anything the agent takes action. For example, a game. Yes. So the agent takes action in the environment and receive rewards or penalties based on the outcome of those actions. So it is these rewards that now guide the agent to learn the best decisions to take. Then what will happen over time? Over time, the agent would have learned action that leads to the most reward. He will now adjust his strategy to maximize the total reward. You like this. So imagine you are training an artificial AI to play a video game. So the game is the environment. The AI is the agent. So the AI tries different moves and strategies to win the game. Each time he makes a good move, he gets points. Yes. Each time makes a bad move, he loses points. So he now learns from that. By playing the game many times, the AI learns which moves are best to win. Yeah. So in short, that is reinforcement learning. So let me just go through. I explained supervised learning. Supervised learning, we have labeled data and we want to make predictions. Unsupervised learning, we have unlabeled data. We want to find hidden patterns. Then reinforcement learning is used when an agent wants to learn by interacting with the environment, and learning by feedback. Learning by feedback. Take note of that word, feedback. Take note of that word. So, yes. So for machine learning, as you can see my screen, for machine learning, one of the best editors, one of the best code editors to use is VS Code. VS Code is very, very nice. It's what I use. It's a free code editor. Yes, it's owned by Microsoft. It's very, very popular among programmers. It's easy to use. It works on Windows. It works on Mac, Linux. VS Code is very, very user friendly to use. Okay, somebody hands raised. Okay, Tosin, your hand is
Hello.
raised. Yes, I
Yeah,
can hear
thank you
you.
very much for thank you very much for your for this session, for this class. I appreciate you. And so my question is you're saying something. It's two questions that I've got. So the first one is about this labeled and unlabeled data for supervised and unsupervised learning under
Yes.
machine learning. So that labeled, so I'm just trying to understand the meaning of the label. When you say the machine tries to learn from labeled data, can I look at it from this perspective? Like when there is a table, a table has maybe employee. Let me use an employee details for instance. A table has the employee number, the first name, last name, age, address, um, uh, the kind of, can I see? I mean, that field name. Is that what you are referring to as label that the machine learns from? Or I'm just
Okay.
trying to understand the label.
Okay. Yes, yes. I understand your question. So let me paint like this. So using the example I gave of if labeled and unlabeled data. So in labeled, we have a target. Labeled data, during the example I gave, like
Mm,
for which example did I give? I gave the example of yes, house price. So we have details
okay,
about the house. We have details about the
okay,
house, like the number, let's assume the features. So look at something, feature and label. Take note of that word, feature and label. So for the house price, what are the features? The feature is the size of the house. Second feature can be number of rooms. A third feature can be location of the house. So these features
okay,
will determine the price. The price is a target. The price is the target. The price is
okay,
our label. You understand? But on label data, the example I
okay,
gave was for this thing. On label data, I use customer segmentation. So when I have the data of my customers, I have their purchase history. Let's assume I own a supermarket, and then I'm studying the purchase. I'm just looking at the purchase history of my customers. Do you understand?
okay,
So there's no target. I just want to look at it. And then I using that data I have about them, I separate them using things that are in common. The keyword here is clusters. Then I study, I have no target in mind. But then when I see the random data, I will not trace out things that are in common and put them in clusters. In supervised learning, I already know something that is my target. The target is price. But on supervised learning, I don't have a target. I just want to put them in clusters based on their characteristics. Do you understand?
okay, okay. Yeah, yeah, yeah. I
Maybe,
get you now.
may-
I get you now.
maybe I should try. Maybe I
I
should try
get.
to explain it.
Okay.
Yes, if you check on the screen now, you will see x and y variables there. So when we are dealing with labeled data, the x is the y is the target variable. So let's say you are trying to study the impact of house prices, I mean house size, the area where the house is put, the number of rooms. You want to check the impact of those things on the price of that house. So you are going to label the target, the price, and then those other features, you're going to label them differently. Maybe you call all of them X, and then you call the house price Y. Because you are labeling them, you are separating two variables. One, the target variable, and then the other one, the estimating variables, those variables you want to use to estimate price. Because they are clearly labeled A and B or X and Y. That's why we call it labeled data. But when you are doing unsupervised learning, there is no X and Y. We are just simply joining things together, and we are trying to find out whether there's a pattern between them, whether there's any visible pattern. For example, putting a lot of clothes inside a box, and then all the clothes have different colors, but we don't yet have a criteria for classifying whether it's a man's cloth or it's a woman's cloth, or whether the cloth is red or green. So the computer simply learns to check clothes that are similar based on certain criteria and put them in certain clusters. For example, if the computer sees that some trousers are long, it may take all the long trousers to one place, take all the shirts to one place, take all the colored ones to one place, take all the blue colored ones, the white colored ones, just by itself. It learns by itself without having a predetermined set of criteria by which it is learning. So that's technically that's the difference between labeled supervised learning and unsupervised learning.
All right.
Do you
Thank you very
understand?
much. And also, yeah. So, oh, sorry. One more thing. The reinforcement learning, the way you explain it, does it look like the machine learns from experience of what has actually occurred and learn from it? Oh,
Yeah.
this thing doesn't. It learns like experience, just like human being. Now, when you do something and you see, this thing is not bad, it's very risky for your health, and you learn that, oh, you don't have to go back to that thing. So I think that's how reinforcement learning is. So you keep learning as I don't know if that makes sense.
Yes, yes,
Is
yes, yes, yes. Thank you very much, Destiny. Thank you so much for that very detailed explanation. Tosin, have everything been clear now?
yes.
Okay,
Thank you
okay,
very
okay,
much.
okay. Thank you, thank you. So moving on, I was talking about the code editor. VS Code is very, 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 very nice. So to use machine learning on VS Code, you have to add extensions. You add the extension of Python, Jupyter notebooks. Yes, these are the extensions you need to write your code. And with with VS Code, you can easily integrate it to JIT to keep track of changes in your code, to collaborate with others. Yes, it has a built-in support for JIT. Where is this button? My screen. It's somewhere at the left. Yes. So that is for JIT. So this is just a basic class. It's a practical introduction. So I'm going to explain the basics. So for machine learning, most times we are going to be using Python. Python is a very popular programming language. It's one of the easiest programming languages for you to learn and work with. I hope you have probably heard about it. Yes. And so Python has several powerful libraries that make it easy to work with machine learning and to make it easy to work with data. So for you to do machine learning, Python is very, very good. You can also use Arrow, but Python is a very, very good place to start. As you grow further, you can learn others and gain experience. So the basic library we're going to be using NumPy. I'm going to just introduce us to three libraries. But as time goes on, you can learn other libraries. But the three libraries I'm going to introduce us to: NumPy, Pandas, Matplotlib. So NumPy is a library that makes working with numbers very easy. It allows you to create arrays. Arrays are something similar to lists, but arrays can handle more complex things. So with NumPy, you can perform calculations on large data sets very quickly, very efficiently. That's for NumPy. Then Pandas. Pandas is for data manipulation. That is what it's basically for data manipulation and analysis. Pandas allows you to work with data in table formats, similar to something in Excel. Yes. So using Pandas, you can load your data from CSV files, Excel files, and SQL databases. And then the third one I said that will introduce us to is Matplotlib. Matplotlib. So Matplotlib is a library for creating visualizations. There's another library you can use for creating visualizations, but let's just start with Matplotlib for creating charts, graphs. It helps you understand your data better by helping you to visualize them. So there's an example we're going to get to, but until we get there, yes. So those are the three basic things I want you to take note of: NumPy, Pandas, Matplotlib. So what I said about VS Code, I want to like it's I will drop a link in case you want to download VS Code. So when you download VS Code, there's a video. I'll drop a video that guides you on how to download VS Code and then add the Jupyter extension. Yes, it's very, very straightforward. I'll drop a video on that. It's very, very straightforward, so you can use it and get ahead. I'll send the recording to your session. I'll send the recording of this session to your mail. I'll send the various links to your mail as well. So then, okay, let's do something practical. Let's do something practical. Let's create a very, very, very simple model. Simple model. Good. I hope you can see the screen. Let me reduce the size of this screen so you can see it clearly. Good. So in this place here, we're going to be creating a very, 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 very simple model. So like I said, I told us what NumPy is. NumPy is used for handling arrays, something similar to lists, but arrays are better for working with data. Arrays are better for working with large data sets. So the first thing we did here is somebody raising his hand. Okay, the hand is raised.
Yes. The question is downloading extension for Jupyter Notebook.
Yes.
Why is it necessary to download it in VS Code instead of just using VS Code Jupyter Notebook like the way you just use it directly?
Okay,
Why
you
do why
mean
do,
use
like
okay.
why should we use the same Jupyter Notebook inside VS Code
Instead
instead
of
of
using
just
it
using
from your browser.
yes.
Okay. For me, I prefer VS Code. VS Code highlights your work. For example, using Jupyter Notebook, if I make errors, it uses IntelliSense. It helps you to write code with fewer errors. VS Code suggests completions for your code when you like use the IntelliSense extension. So using VS Code is
Uh,
more simpler for me. You can integrate your code with JIT. Where is it? This is it. Yeah. Yes, you can integrate your code with JIT. So keep track of changes of your code. Probably if you're working with several people, you can easily push it to GitHub from here. So for me,
uh,
working with Jupyter Notebook in VS Code, it helps me to manage my everything I'm doing more properly. My folders, everything. The UI is more friendly. Look at it, very, very clean, easy to navigate. Look at even if you are very, very new to programming, by just looking at this, it's very easy to know what this is for. I don't know if you understand what I mean.
okay.
So using it in VS Code is very, very it's more friendly. It just makes the work easier for you. It can do the same thing just as that one you use, but using this just makes everything easier.
All right. Thank
Okay,
you.
okay. So I was explaining what we're going to be doing here. So the first thing what I said we'll do is to import NumPy. Please give me a second. Okay, yes, the first thing we're going to do is to import NumPy. And then this sklearn, this here, don't worry, this looks strange. I'm going to drop resources so that you learn several of these things that are very important. The essence of this thing here, this thing that I just highlighted, is just to create the model and train the linear regression model. So here we're going to build a very, very simple linear regression model. Just understand, you might know everything here might look strange, but one thing about machine learning, the more you practice, the more you get better. The more you practice those things that were seemingly strange to you, you become better at understanding what this is, what that is. So just observe it, observe the steps. I've explained the steps, create the data, train the model, test the model, understand the steps, various things, keep learning them. The more you practice, the more you practice, the more you become better. It's not something that happens one day where you just become experienced and just you cannot really understand machine learning fully by just being on this 1 hour call or 30 minutes call. It's continuous practice. To become a professional, you keep practicing, keep taking courses, keep working on projects. Very, very important. It's not just to keep taking. There are a lot of people that are lost in this tutorial loop. They have taken courses, training. But when we look at projects they have worked on, they have not really worked on any project. Yes, so that is the thing. It starts from somewhere, but then you keep making progress. You keep learning more. I'm going to drop Microsoft Learn is a very, very free resource. You can learn anything. You don't have to pay anything. You get your certificates. Microsoft Learn is very, very, very free resource for you to learn. I'll talk more about that after this, but let me just continue explaining this code. Yes. So after you have imported these necessary things, yes, the next step is to create your data. So in this simple model we're creating, like I said, machine learning, it learns from data. And then with this data, it can predict, it can make new decisions. So this first data, it contains the number of hours studied. The second one contains the number of scores obtained. If we were to plot this thing, we should know how it will look like. I'll show us how it's plotted later, but if we were to just imagine it, it's just going to be very simple plots. So when we have the data, the next thing to do is to train the model. This creates the instance of this class. So you train the model using this data. Good. So after you have done this, I hope you can see what I just highlighted. After you have done this, you have trained the model. So then we can now test our model. For example, I trained this model on 4, 8, 12. This is the hours where this is the scores obtained. And I'm not giving it. What if I read for 6 hours? If I read for 6 hours, what will be the results? Good. Predicted score for studying for 6 hours is 24. It's a hand raise. No. Good. So this is it. I've trained it on this data here. This data, this is where this is the data. This is where I trained it. Yeah, I created the instance of this class. Here is where I trained the data. So now I'm not testing it. I've trained it on this data. So now you already understand the relationship between the hours people study and the score they can obtain. He has already understood it. Good. So when he has understood it, I can ask it, what if someone is reading for 6 hours? What is the score? Then you cannot give me 24. And the one thing I want to say is that somebody cannot look at it and, okay, let's look at it. Let's be very realistic. Somebody can read 1 hour and get a score of 4. But it's possible that somebody can read also for like 6 hours and not even get up to somebody that read 2 hours if we are to be very, very realistic. Clearly, the thing, machine learning might not be as realistic as you think, but it makes decisions based on the data that it was fed with. Everything it knows is everything you fed it with. If you feed it with garbage, it produces garbage. Yes, it's that simple. So machine learning is just the only intelligence it has is the intelligence you fed it with. It does not have intelligence on its own. So predicted score for studying for 6 hours, yes, that's 24. So this is a very, very simple model. We built a model to predict the number of someone's score from the number of hours they have studied. Yeah, so I also visualized it. Yes, I thought earlier I spoke about NumPy, I spoke about pandas, I spoke about matplotlib. Yes, I told us matplotlib is used for creating plots and charts. So this is it. This is the plot. A second, it's loading, it's loading. Yes, look at the plots. I hope you can see this very clearly, very clearly. So this is it. Somebody studied for 1 hour. What would the person's score be? Person's score will be 4. That is what we fed it with. Look at the data I fed it with here. Study for 1 hour, the score is 4. Study for 2 hours, the score is 8. Yes, that's just here. Study for 2 hours, score is 8. Study for 3 hours. Yes, so he has fitted the line. This is a very, very simple linear regression model. So then we now ask it, what if someone is studied for 6 hours? Imagine this line continuously drawn. Yes, if someone is studied for 6 hours, then what would that be? Person score will be 24. So that is very, 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 very simple. Everything about how this plot is labeled, I'm going to drop some resources that we are going to follow, just following those resources on how to understand most of all these things. But I want to believe like we understood this very, very simple example I just explained here. Does anybody have a question? Is there any question?
Yeah, yes, I do.
Okay.
Yeah, my question is, whenever I hear this, like the process that you've explained from loading data, okay, creating data and getting a trained model and all that, and up to the output that you're getting, like let's say in the visualizations and also the prediction, this process looks like it looks the same as, they say, the kind of output you'll get if you're using other applications, like let's say SPSS. You want to do this. Okay, let me talk of regression that you can run in let's say SPSS, or maybe even in Excel. But then as you're running in those applications, you're not going through all these processes, like knowing that now I'm creating, or I'm training a model. You just put that information and finally you get the output. So should we say that those applications inside them, they have this kind of a machine or this algorithm that is doing that, only that we are not doing it by ourselves to do this step by step and all that? I don't know if you heard my question. Hello?
Hello, is anyone here?
Yes,
Hello.
myself.
Yes.
Uh, Hello.
Hi.
Hello.
Yeah,
Hello.
I think it's only Mr. Osehon who is not on the line.
Hello?
Need someone to confirm. Just confirm if you can hear.
Yes.
Okay. My apologies. I had issues with internet connection. So you were asking a question.
Yeah. The question was the example that you just gave here, where you are talking about the target, things like those. Uh, the process that you showed us from having your data and training the model up to having the output up to visualization. If I look at the process, I'm seeing that it's a predictive process, like you are trying to predict, let's say, Y variable on the basis of X variables that you are given. Now, looking
Yes.
at that process, it looks like almost exactly what other applications, like let's say SPSS or even Excel, they can also run a regression like that. But then when you're running like that in those other applications, you don't say that you're doing machine learning. You just say, okay, I'm doing regression. I'm doing, that kind of a thing. So is it like here we're just being technical, but it's the very same thing that other applications are doing. They're also doing machine learning, but only that maybe we don't go through the processes like saying that now we are training the model, or because we don't do that, just give it data, it gives you the output, but you don't say I'm training the model and I'm doing all those things. So is it the same thing?
Okay. I understand the question. For most of those software, some of those software are built with these algorithms in the background. So when they are working, those models, they are already been built with these models. So they're giving you output based on how they have been built. And it's me in this example, in the example I gave, I was just trying to break everything down. I don't know if you understand. I was not trying to
Yeah.
break everything down, but you can build those systems are already built already with this model at the background.
Okay, so we can say that even inside Excel, those machine learning algorithms are inside there, are built
Yes,
inside it.
you can build machine learning models with Microsoft Excel. They have some updates. You can build machine learning models with Microsoft Excel.
Okay.
Okay.
All
Does anybody else
right.
does anybody else have a question?
Yes, I have a question.
Okay.
Good evening.
Good evening.
Yes. So from the example you gave, I think you've touched it while I asked you, you've touched a part of my question. I was going to ask that. So is it the linear regression you imported that is now the machine learning algorithm? So I think you've mentioned it. You've answered that. But then, so what category of machine learning does it fall into? Initially you mentioned supervised, you mentioned unsupervised, then reinforcement. So then another question is, at what point do you use an algorithm from those categories? Does it depend on the type of data you have, or the type of model you want to create, or the type of maybe software or something you want to work on?
Okay. Okay, I got your question. The first question, let me explain it. So for supervised learning, I said that it has it has a label, it has the features and it has a label. The label is depending on the features. You remember that, right? So
Yes.
in this example I just gave, the scores obtained is dependent on the hours studied. So this is an example of supervised learning algorithm. Is it clear?
Yes, it is.
Okay, so then for the second one, your question was okay. Yes, I remember your question. This is it for that. The thing is that there are various use cases, various problems. There is based on what you want to do, based on the type of data, based on the type of problem. That is how you know the machine learning algorithm used for that type of problem. For example, let's assume I want to build a model that can, let's assume I was a medical professional, and then I want to build a model that something that if I can just snap an image of this, somebody, let's assume people have skin disease. If I can snap an image of a skin disease, it will tell me the skin disease. Just pay attention. So look at, for that type of problem, let's now brainstorm. What type of algorithm should we use? Look at it. We're going to study images of data. For us to do that task, we have to study various images of data of people with various skin diseases. Are you following? Various skin. So these various skin diseases, let's assume we are working with 10 skin diseases. So for these various 10 skin diseases, we have like 10,000 images each. And then with these images, we also have a name. So then we train this machine learning model with this is the image. For these 10,000 images, this is the name. So then when we have trained it on something like that, then someone can take a picture of somebody's hand with a skin disease and it cannot tell us the name of that skin disease. For this example, the approach we used was supervised learning algorithm. So there's no like, it depends, you brainstorm on for this problem to get your desired solution. What is the best way? The best way. Do you understand? The best way. So we're looking at the best way to get your desired results. You understand that, right?
Yes, I get
Are
it
you
now. Thank you.
okay? So very quickly, we're going to be looking just a quiz to revise the few things we learned here. So just give me a minute. Let me launch the poll. So it's just a quiz. Just revise the various things you learned. Okay, I've been launching it now. So, okay, look at your screen. You'll be able to see the quiz. Can you see it?
No, I can't.
Look at your screen. Look at your screen.
Yes, I can.
Okay. Just pick the correct answer. Pick the correct answer. What is machine learning? Is it a computer game? Is it a programming language?
Sorry,
What
I
did you
can't
say?
see the quiz though.
You cannot see
I
any
can't
quiz.
see the quiz.
There's nothing on
I
my screen.
okay.
I think you
I
guys should
think
check the chat box.
There's nothing on my screen.
check the chat. Check the chat. Can you see it now?
Yes.
Yes. So, what do you think is the answer to number one? What is machine learning? Is it a computer game, a way to teach computers to learn from data, or it's a programming language, right? Pick your answers. Pick your answers.
You can't pick answer here.
Sorry, I can't. Okay.
I can't pick any answer because I'm not logged
Can
in.
you pick an answer now? Gosh. Okay. I don't think
I
everybody
can't
was
pick
able
an
to do
answer
that.
because I'm not logged in. They said we have to log in first.
Wàhálà yín pọ̀.
Where are you from? Yes. Boy. Where are you from?
Instances the model is most uncertain about.
Okay, let's end the poll. Let's just round off. Let's round off. Okay, just to reflect on everything we learned. So first of all, we started by looking at machine learning. I defined what machine learning is. I gave us practical examples: email filtering, recommendation systems, image recognition, and then I differentiated between artificial intelligence, machine learning, and deep learning. Don't worry, I'll send the recording of this session to your mail as far as you registered for this event. And then also look at types of machine learning: supervised learning, unsupervised learning, reinforcement learning. And then I told us the difference between them is very simple to identify. Supervised learning is supervised learning is labeled. We have labeled data to make predictions. Unsupervised learning, unlabeled data, we're finding hidden patterns. Reinforcement learning, we learn by receiving feedbacks. And then we built a very simple linear regression model. We plotted it here. So that's all for today. So very quickly, I want to drop resources. I mentioned I'll drop a resources. Where's the chat? Yes. So these links, I sent 4 links. Well, I've seen the links, right? Okay, if you check the chat section, I just sent I sent 4 links. Yes. So there are courses on Microsoft Learn. Microsoft Learn is free. There are a whole lot of courses you can learn. For machine learning, everything you need to know about machine learning from your beginnings to advanced, you can just follow Microsoft Learn. A lot of resources. Follow these links: how to use Jupyter Notebook with VS Code,